Hello everyone, today is a new day, new life, new beginning, and new lesson. Once again, I'm teacher Angie. Our lesson for today is about word problems involving direct variation and direct square variation. Before we're going to proceed, let's review first what is direct variation and direct square variation. Direct variation, a simple relationship between two variables. The statements y varies directly as x, y is proportional to x, and y is directly proportional to x may be translated mathematically as y is equal to kx, where k is the constant of variation and y and x are the two given variables. Main equation natin for direct variation is y is equal to kx. Next, direct square variation. The expression y varies directly as the square of x can be expressed through the equation y is equal to kx squared, where k is the constant of variation, that is the ratio between y is equal to x squared and y is directly proportional to x squared. The equation for direct square variation is y is equal to kx squared. Instruction. Solve the following word problems involving direct variation. Example number 1. A worker paycheck P varies directly as the number of hours H work. For working 20 hours, the payment is 1,000 pesos. Find the payment of 45 hours of work. First, we need to give the representation. P, worker paycheck. H, number of hours work. And of course, for our given, we have P1 is 1,000. P2 is the unknown. H1, 20 hours, and H2 is equal to 45 hours. For our equation, P is equal to KH for our variation, and P is equal to P1 over H1 for our constant. For solving for K, K is equal to P1 over H1. Then substitute. P1 is 1,000 divided by H1, which is 20. So for our K, we have 50. Solving for P sub 2 is equal to K, which is 50 times H sub 2, which is 45. Therefore, our P2 is 2,250. Next, we're going to use ratio and proportion. So for our P1 and H1 is equal to P2 over sub 2. Then substitute the given. For P1, we have 1,000. H sub 1, 20, is equal to P sub 2, which is the unknown, all over H sub 2, which is 45. After that, we need to get their cross product. So 20 times P sub 2, we have 20 P sub 2. And 1,000 times 45, so we have 1,000 times 45. 20 P sub 2 is equal to 1,000 times 45 is 45,000. Then to isolate P sub 2, we need to divide both sides by 20. Therefore, we have 20 P sub 2 divided by 20 is equal to 45,000 divided by 20. Then cancel na natin si 20 and 20. Then we have P sub 2 is equal to 45,000 divided by 20 is 2,250. So the answer are the same. Okay? Next, example number 2. Example number 2. A mailman can sort out 738 letters in 6 hours. If the number of sorted letters varies directly as the number of working hours, how many letters can be sorted out in 9 hours? We need a representation first. L, for the number of letters the mailman sort out. H, for the number of working hours. Given, L sub 1, 738. L sub 2 is our unknown. H1, we have 6 hours, and H2, we have 9 hours. For our equation, for variation, L is equal to KH, and for our constant, we have K is equal to L sub 1 over H sub 1. Solution for K, K is equal to L sub 1 over H sub 1, then substitute the given. K is equal to 738 divided by 6, and K is equal to 123. Solving for the variation, we have L sub 2 is equal to KH sub 2 because we're going to use this one. Then substitute the given. L2 is equal to, for our K, we have 123 times H sub 2 is 9. Therefore, our L sub 2 is equal to 1,107. Solution number 2, we're going to use the ratio and proportion. So for our equation, we have L sub 1 all over H sub 1 is equal to L sub 2 over H sub 2. Then substitute the given. For L sub 1, we have 738 all over H sub 1, which is 6, is equal to L sub 2, which is our unknown, divided by H sub 2, which is 9. Then after that, kunin natin ang kanilang cross product. So 6 times L sub 2 is equal to 738 times 9. 6 L sub 2 is equal to 738 times 9. We have 6,642. So to isolate L sub 2, we're going to divide both sides by 6. Therefore, we have 6L sub 2 divided by 6 is equal to 6,642 divided by 6. So cancel na natin si 6 and 6. Therefore, we have L sub 2 is equal to 6,642 divided by 6 is 1,107, which is the same with this one. Next example, example number 3. The area A of a square varies directly as the square of the length of a diagonal D. If the area of the square is 8 centimeters squared and the diagonal is 4 centimeters, find the length of the diagonal if the area of the square is 144 centimeters squared. Next, we need to get the representation first. So for our A, we have area of the square. And for our D, length of the diagonal of the square. What are the given? A sub 1, we have 8 centimeters squared. A sub 2, we have 144 centimeters squared. And for our diagonal or D1, we have 4 cm. And D2, which is our unknown. Equation for our variation, A is equal to KH squared. For our constant, K is equal to A sub 1 all over D sub 1 squared. Solution, in solving for K, we have K is equal to A sub 1 all over D sub 1 squared. Then substitute the given. A1 is 8 centimeters squared all over D sub 1, which is 4 centimeters, and then squared. Don't forget the squared because that is very important. So first, we need to square the bottom, which is 4 centimeters squared. So we have now 8 centimeters squared all over 4 squared is equal to 16, and then centimeter squared is centimeter squared. Then after that, cancel centimeter squared and centimeter squared. Then 8 over 16. So 8 over 16 are both divisible by 8. So 8 divided by 8, we have 1. And 16 divided by 8 is 2. Therefore, we have K is equal to 1/2. Solving for D sub 2, so we have now A sub 2 is equal to KD sub 2 squared. Then substitute the given. We have 144 centimeters squared is equal to, our K is 1/2, and then D sub 2 squared. And of course, to isolate D sub 2, we need to multiply both sides by the reciprocal of 1/2, which is 2. So we have now 2 times 144 centimeters squared is equal to 1/2 D sub 2 squared times 2. Then cancel natin ang 2 and 2. Why? Kasi this 2 is a whole number and this is the denominator for fraction 1/2. Then next, 1 times D sub 2 squared is equal to D sub 2 squared. And then 2 times 144 centimeters squared is equal to 288 centimeters squared. To find d sub 2, we need to find first a factor of 288, wherein one of the factor is a perfect squared. So we have 144 times 2 centimeters squared. Then, we need to write it in exponential form. So we have 12 squared times 2 centimeters squared is equal to d sub 2 squared. Then, to extract the square, we need to put radical sign on both sides. So we have now square root of 12 squared times 2 centimeters squared is equal to square root of d sub 2 squared. Then we're going to bring out all the perfect squared. So we have this one and this one. Therefore, we have d sub 2 is equal to 12 square root of 2. And then, of course, yung 2 cancel din, kaya centimeter na lang siya. Bakit ang 2 nasa loob pa rin ng radical sign? Yes, because those are not perfect squared will still remain inside the radical sign. Therefore, we have d sub 2 is equal to 12 square root of 2 centimeter. Okay, next. Example number 4. The area A of a certain regular polygon varies directly as the square of its side is. If the area of the polygon is 150 centimeters squared, when its side is 5 centimeter, what will be the new length of each side if the area will be increased by 336 centimeters squared? Okay guys, remember the word increase. Next, of course, we have the representation. A is equal to area of a certain polygon as the length of the side. And then, given S sub 1, we have 5 centimeter. A sub 1 is 150 centimeters squared. And then for S sub 2, unknown. And then A sub 2, we have 336 centimeter squared plus 150 centimeters squared. Why? Because from the word increase. So we're going to add these two, and then our A sub 2 is 486 centimeter squared. For our equation, for our variation, we have A is equal to KS squared. And for our constant, K is equal to A sub 1 over S sub 1 squared. Solving for K, we have K is equal to A sub 1 all over S sub 1 squared, and then substitute. For A sub 1, we have 150 centimeters squared all over. S sub 1 is 5 centimeter and then squared. Of course, unahin natin ito kasi naka-squared siya. Next, so 150 centimeters squared is 5 times 5, we have 25, and then centimeter squared is equal to centimeter squared. Cancel na si centimeter squared and centimeter squared. Therefore, we have, for our K, 150 divided by 25 is equal to 6. Next, solving for S sub 2. So the solution is A sub 2 is equal to K S sub 2 squared. Then, of course, substitute. For A sub 2, we have 486 centimeters squared is equal to K is 6, and then S sub 2 squared. Then we need to isolate S sub 2, so we need to divide both sides by 6. And cancel 6 and 6. So we have S sub 2 squared is equal to 486 centimeters squared divided by 6, which is 81 centimeters squared. And then to extract the square, we need to put radical sign both sides. So we have square root of S sub 2 squared is equal to square root of 81 squared. So if you don't have calculator, you can do this. Pag-isip ng factor ng 81 wherein one of the factor is a perfect squared. So, since 81 is a perfect squared, which is 9 times 9 or 9 squared, so we have 9 squared. And then, after that, cancel na natin yung mga perfect root, which is itong squared and then the radical sign, squared, squared, and the radical sign. And then, of course, we have S sub 2 is equal to 9 centimeter. Next. Example number 5. The area A of the circle is directly proportional to the square of its radius. The area of a circle whose diameter is 40 centimeter is 1,256 square centimeter. What is the area of the circle whose diameter is 10 centimeter? Representation, A is equal to the area of the circle and for our radius of the circle. Next, given A sub 1 is equal to 1,256 square centimeter and A sub 2 is the unknown. And for our R sub 1 radius, okay, so if you notice, ang given dito is diameter. Pero we need R. So anong relationship ng diameter and radius? Remember that radius is equal to 1/2 of the diameter. Therefore, 40 divided by 2, which is we have 20 centimeter. And for our R sub 2, 10 centimeter, diameter siya, kaya 10 divided by 2 is equal to 5 centimeter. Next, of course, equation. For our variation, A is equal to KR squared. And for our constant, K is equal to A sub 1 all over R sub 1 squared. And for our solution, solving for K, we have K is equal to A sub 1 all over R sub 1 squared. Then substitute the given. K is equal to 1,256 centimeters squared all over 20 centimeter squared. And then, of course, we need to square first the denominator. So we have 1,256 centimeters squared all over 20 squared is equal to, or 20 times 20 is equal to 400. Centimeter squared is equal to centimeter squared. And of course, next, we need to cancel centimeter squared and centimeter squared. Now, divide 1,256 divided by 400. So we have K is equal to 3.14. Now, solving for A sub 2, we have A sub 2 is equal to K R sub 2 squared. Then substitute the given. A sub 2 is equal to, for our K, we have 3.14 times R sub 2, which is 5 centimeter, and then squared. So we need to square first our R. So we have now 300.14 times 5 times 5, 25. And then centimeter times centimeter, we have centimeter squared. Next, 3.14 times 25 centimeters squared, we have 78.5 centimeters squared. Therefore, our A sub 2 is 78.5 centimeter squared. Next, example number 6. The shadow S of an object varies directly as its height, h. A man 1.8 meter tall casts a shadow 4.32 meter long. If at the same time a flagpole casts a shadow 12.8 meter long, how high is the flagpole? Representation, S is equal to shadow of an object, h is for the height. And for our given S sub 1, we have 4.32 meter long. And for our S sub 2, we have 12.8 meter long. Next, H sub 1, we have 1.8 meter. And for our H sub 2, that is the unknown. For our equation, for our variation, we have S is equal to KH. And for our constant, K is equal to S sub 1 all over H sub 1. Solution solving for K, we have K is equal to S sub 1 all over H sub 1. Then substitute the given. S sub 1 is equal to 4.32 meter divided by H sub 1, 1.8 meter. Then, of course, we need to cancel meter and meter. Then, divide 4.32 divided by 1.8. So, we have K is equal to 2.4. Next, solving for H sub 2, we have S sub 2 is equal to K H sub 2. Then, substitute the given. 12.8 meter is equal to K, which is 2.4 times H sub 2. To isolate H sub 2, we need to divide both sides by 2.4. So we have now 12.8 meter divided by 2.4 is equal to 2.4 H sub 2 all over 2.4. Then cancel 2.4 and 2.4. Therefore, we have H sub 2 is equal to 12.8 meter divided by 2.4. We have 5.33 meter. Therefore, our H sub 2 is 5.33 meter. Therefore, the height of the flagpole when the shadow is 12.8 meter long is 5.33 meter. Example number 7. The amount of paint P needed to paint the walls of a room varies directly as the area A of the wall. If 2 gallons of paint is needed to paint a 40 square meter wall, how many gallons of paint are needed to paint a wall with an area of 100 square meter? First, of course, we need the representation. For our P, amount of paint needed to paint a wall. This one. And for our A, the area of the wall. Next, what are the given? For A sub 1, we have 40 squared meter. And for A sub 2, we have 100 square meter. And for our P sub 1, we have 2 gallons. And for our P sub 2, that is for our unknown. And for our equation, for our variation, P is equal to KAY. It says here P, how or the amount of paint P needed to paint the wall of the room varies directly as the area of the wall. Therefore, we have P is equal to KA. For our constant, K is equal to PA all over A sub 1. Next, solution for our K, we have K is equal to P1 over A1. Then substitute the given. For P1, we have 2 gallon all over A sub 1, 40 meter squared. Then for our K, we have 120 gallon per meter squared. And for our P sub 2, we have P sub 2 is equal to K A sub 2. Then substitute the given. P sub 2 is equal to, for our K, 120 gallon per meter squared times ang A sub 2 natin ay 100 meter squared. Then, cancel na natin ang meter squared and meter squared. Then, after that, we're going to multiply 100 times 1 over 20. So, pwede nating i-cancel si 20 and 100. So, 20 divided by 20 is equal to 1. And 100 divided by 20 is equal to 5. So, 1 times 5 is equal to 5. And of course, gallon na remain. Therefore, our answer is 5 gallon. Therefore, the number of gallons of paint needed to. Therefore, the number of gallons of paint needed to paint a wall with an area of 100 square meter is 5 gallons. That's all for today. I hope you learned something from this video. Thanks for watching. Please do watch, like, share, and subscribe. Keep safe. God bless us all. Bye.